Alright, today we're going to talk about direct and inverse variation. And the way that you could have known that before I told you was, it's the title of the worksheet, right? Direct and inverse variation. Plus it's in the lesson plans that you have already written down from the board, correct? Excellent. So let's go through some of these problems. We're going to go through the problems first and then we're going to discuss them. Okay, but we need to get some data to begin with, so let's go through the problems. A square with a side length x units has a perimeter of y units. So how would we go about finding perimeter? Add up all the sides. Specifically, how do we find the perimeter of a square? Y equals 4x, right? Yeah. S if the side was s, but our side is x, so we would just say 4x, right? Okay? So if x is 3, what's y? 12. And how do you know that? Because you multiplied it by 4, right? Okay, so then somebody tell me 7.5 and somebody tell me 9.5. Let's use the properties that we just talked about. What's 7 times 4? 28. And then what's half of 4? 2 more, so this is 30. See, we didn't even need no stinking calculator. What's 9 times 4? 36. And what's half of 4? 2, so 38. I mean, you can check my math with your calculator, but, I know it's right. Okay? Alright, what about this one? The rectangle with a length of x units and a width of y units has an area of 60 units. How do we find area? So x times y equals 60. Well, that's all fine and good, but what if I want it y equals? Oh, divide both sides by x. Okay, so y would equal what? 60 divided by x. Good. So when x is 4, what's y? Good. 15. When x is 8, what's y? Yeah, some of you are using your calculator. Good job. I know this is 5. What's 8? 7.5? 7.5? Okay. Good. Alright, what about the next one? A man 5 foot tall casts a 3 foot shadow. At the same time of day, a tree y feet high casts an x foot shadow. Just for the record, people in earlier classes were sad for this man, because he's only 5 feet tall. I told them that was, I appreciated their generous spirit, but we shouldn't make fun of a man who's 5 foot tall. Because he could be a perfectly nice man. Yeah. We don't need to judge people just because of how tall they are. Right? Okay, good. So what kind of equation do we have? This is a little different, right? We maybe need to do some little side work first. Do you know how to solve this problem? Pythagorean theorem is one possibility, but we don't really you need it here, because we don't know about stuff here. We're not looking for this diagonal right here. We know width and length and height is what we know. That's a good guess. We could, or we could just use a ratio, right? A proportion. Couldn't I do that? So I could say the height over the length of the shadow equals the height over the length of the shadow. And then I could cross multiply, right? If I cross multiply, I get 3y equals 5x. And how would I solve for y? Divide by 3. So y would equal what? Yeah, 5x over 3 or 5/3 x, right? Excuse me. So I know this one off the top of my head. I can do that one. What about the other two? .5 is 7.5. Excuse me. And then what about 10.5? What is it? Thank you. 17.5. Okay so far? Okay, what about this one? A person 60 inches tall looks through a mirror 30 inches from the wall. If she's X inches away, how far Y up the wall can she see? It was funny because I didn't really feel sorry for this person. Why? Yeah, it's a girl. Girls are allowed to be 5 feet tall. I told them that was pretty judgmental and strange. So do you still want to set up a proportion to solve this side? Would that be the best way? Yes. Okay. What proportion would you set up? For the record, there's not just one right answer. This is not the only proportion we get to set up to solve this one. So start with something. What do you want me to write first? So if we do y over 30, that means we did the short part of the triangle over the long part of the triangle. So over here, this needs to equal the short part of the triangle over the long part of the triangle. So 60 over x. Remember this? Remember how to write proportions? Okay. If I cross multiply, I get xy equals 1800. So that's one form of our equation, right? But what if I just want to solve for y? What do I do? So y would equal 1800 over x. Very good. Got those two. Can you do those two in your head, by the way? What's 18 divided by 2? 9, so 90. What's 18 divided by 6? 3, so 30. You okay with that? So what's 18 divided by 4, or 40? 1800 divided by 40. 45, thank you. Okay, so far? I just want you to get some more practice doing math in your head. So I'm trying to show you how I think about it and stuff like that, okay? For X people to travel, the cost Y in dollars for renting a bus at $7.50 per person. What's the equation? 7.5x. Very good. It says that it's $7.50 per person. The total cost Y is $7.50 per person. So the per usually means multiplication when we're doing word problems like that. Okay? All right. Did you fill out the table for me? What is it? 187.5. Ignore that other point. There's the point we need. And 225. Good. All right. What about the last one? This one's a little different because it says the bus will cost $180 to rent. If X people ride, how much will it cost per person? So the number of people times how much it costs is going to equal 180 total, right? The bus will cost $180. It will be $180 if X people ride per person. Y. Yes? So what would it be if it was solved for Y? 180 over X. Okay? So if we fill in our table, is that right? 22.5? Okay? So let's talk about this in general. We're still looking at this side, so let's talk about this in general, okay? Let me zoom out a little bit so we can look at all of this. I want you to look specifically at the X columns of the table. in this first column. We're not looking at this side right now. We're only looking at this first column over here. Okay? What do you notice about the x values in each of the tables? Does it? It's increasing, isn't it? This increases, and this increases. Right? What do you notice about the y column in each of these tables? They're also increasing. Okay? Look at the second column of information now, just the stuff over here. What do you notice about the x column? It's increasing. What about the y column? Ooh. Dun, dun, dun. Okay? So the first column of data, x increases and y increases. The second column of data, x increases, y decreases. Why do you think I would group the first column of problems together, and then why do you think I would group the second column of problems together? But I mean, like, why? Like, what would put them together? Could we compare their equations? How could we compare their equations? Do these look similar? How do they look? Y equals what? A number and x, right? In math, we call that a constant, right? And because we apparently can't spell, we use the letter K to symbolize constant, right? So we have y equals kx. Do you agree with that? What about the equations over here? What's weird is over here, didn't I write two equations for each one? Are they two different equations? No? It's just, here's one equation and then I solved it for y. Here's one equation and I solved it for y. Why didn't I do that over here? I already had y, right? Okay. So what would these equations over here look like? It could equal y equals k over x. What's another possibility? xy equals k, right? Well, what if I had x and y on the same side over here? What would that look like? Yeah, it would be y over x equals k, wouldn't it? Because I'd have to divide both sides by x to get the x and y on the same side, or better yet, to get the k by itself, right? Because here the k is by itself, and it happens that both x and y are on the same side, and they're being, what? Multiplied. So if they're being multiplied, what do they have? They have a constant product. Right? It's constant product. What about x and y on this side? They're being divided. So what do they have a constant? Good. Any questions so far? Then let's go on. Oh, look at this. What a coincidence. Tables 1, 3, and 5, this far column, if x blanks, then y blanks. What is it? Increases, then y increases. What about problem 2, 4, and 6? This column over here. If x increases, you're great. If x increases, then y decreases. So are we really paying attention to x very much? No, just enough to see that it increases, because both of the problems that we're going to talk about today, x increases. Okay? What kind of relationships did you just tell me they had? X and y have a constant ratio. X and y in this side had a constant product. Their equations, this one was y equals kx, or y over x equals k. Knowing that those are not two different equations, they're just the same equation solved for two different variables, right? In this side, it was y equals k over x, or x times y equals k. So what are they called? What are our two options? Direct and inverse, you just knew that inherently? I'm so proud of you. Oh, you didn't know it inherently? Oh, it's the title of the worksheet, right? Okay, that's good. That's good. So which one's which? You think this one's inverse and this one's direct? So let me tell you this before we put it down for sure. We've been doing direct variation for a really long time. I mean like since 8th grade, really long time. Although we didn't really always call it direct variation, and most of the time we didn't use a k. We used y equals mx, and sometimes plus b, right? Oh my goodness, I just saw these light bulbs come on, right? So which one's direct variation? Left side. And then this one's inverse. So if we're going to do a sample problem, which we will, the first one, we know it's going to be direct variation. What's going to go in that blank? It's got to be an adverb. What's an adverb again? And it ends in ly. Most of the time adverbs end in ly, right? So what word is going to go in this blank? Directly. Excellent. If y varies directly as x and y equals 12 when x equals 8, then what is y when x is 24? Well, you guys know I like to have like a structure to things, right? And you also know that I always tell you that there's probably other ways to do stuff. I know very well there's other ways to do stuff, but I'm going to teach you the way that is a structured way for those of you that need the structure, and it works every time. Fair enough? Okay, so the very first thing we need to do, looking at the equations we have to use, of these equations, what don't we know? We don't know k. The first thing we need to do is we need to find k. If I'm going to find k, which one of these two things you think I might use? Again, same equation, solve for a different variable. We probably need to use y over x equals k, right? Now, do we know a y value from what we're given? We're given a pair, right? Y is 12 and x is 8. We know it varies directly when y is 12 and x is 8. So if I put in a 12 here and an 8 here, that should give me k, shouldn't it? In this problem, what is k? 1.5. All right. K is 1.5. Okay, so is k 1.5 in every problem? Dang it. I wish it was, right? That would be nice. But it's not. We have to use the information we're given to find k. Then, what do we have to find? We have to find what it asks us for. Now we can find y. Now that we know k, we can find y. And guess which equation we'll use this time? Y equals kx. Because we know k and we know x, don't we? K is 1.5. We just found that. X is what? X is 24. What's 1.5 times 24? 36. So let me see if this makes sure. I don't even know what I'm saying. Let me make sure this makes sense. That's what I meant to say. X is 8, y is 12. X is 8, y is 12. Now, x was 24, and y is 36. Does that make sense? What's supposed to happen in direct variation with the table? They're both supposed to increase, right? Is x increasing? Is y increasing? Good. Do they have a common ratio? What's 36 divided by 24? Do it. 36 divided by 24, what is it? 1.5. What's 12 divided by 8? So do they have a common ratio? Yes. So this is direct variation. Let's try the inverse variation problem then. What should we do first, do you think? Find k. Same as the other one, right? We still have to find k. So let's find k. Well, let's use the equation that's already solved for k. xy equals k. Do I know x and y? Oh, sorry. I forgot to fill in this blank. What goes in this blank? Inversely. Again, it's an adverb, right? You okay with that? Yeah, you're a weird word too. You're welcome. X is 8. Y is 12. This time they have a common product, right? So we multiply them. What's 8 times 12? 96. So 96 equals k in this particular problem, right? So now let's use the other equation of find y. Y equals k over x. So find, well, not number 1 anymore. Find y. Y equals k over x. Well, k is 96. X is what? 24. What is 96 divided by 24? Of course it's 4. Does that make sense? The first x was 8. The second first y was 12. The second x was what? 24. The second y was 4. Is x increasing? Is y decreasing? Do they have a common product? What's 8 times 12? 96. What's 24 times 4? Oh my goodness. We are amazing. Look at your other worksheet, please. That's your homework problems. Psst. You have 4 tables to look at, and then you have 6 problems down here. I'm not going to do any more of these because I already did them on the samples on the other pages, but I want to look at these tables real quick. Okay? It says identify whether each table shows direct variation, inverse variation, or neither. I hate when they throw that neither in there because then I really have to know what I'm talking about, right? How am I going to decide if this is direct or inverse, first of all? What's the first thing I can look for? Increasing, increasing, or increasing, decreasing? Which one is it? Increasing, decreasing. So my first guess might be inverse, right? But for it to be inverse, I have to have a constant product. 4 times 110? 440. 5 times 88? 440. 8 times 55? 440. So what kind of variation is this? Inverse. We're positive. It's not just a guess. We're positive, right? So when you're looking at these tables, look for increasing, decreasing, or increasing, increasing, and then see if it's direct, they have to have a common what? Ratio. And if it's inverse, they have to have a common product. And if it's increasing, increasing, and they have a common ratio, it is direct. If it's increasing, decreasing, and they have a common product, it is inverse. If one or the other doesn't happen, what is it? Neither. Okay? Do you have any questions on that? Any questions? All right. Peace.